In this lesson we will learn how to use Docker Compose to handle multiple containers. In a previous video I've already presented the basis of Docker and how to build the Docker image of a simple Python application and run it in a container. We will see how to build a web app in Python with Flask that insert and query data from a PostgreSQL database. The web app and the database will run on separate containers and they will be handled through Docker Compose. While Docker is designed to launch a single container, Docker Compose is a tool for defining and running multi-container Docker applications. Docker Compose uses a YAML file, usually named dockercompose.yml, to define the services, networks, and volumes needed for your application. This makes it easier to manage complex applications with multiple containers. It simplifies the workflow for spinning up and managing multiple containers, including defining dependencies between services. For this tutorial I'll use Versus Code as code editor. For this project we're going to create several files. The final structure will look like as shown. You will find the GitHub link to the full project in the video description. Let's start by defining the Python app and related HTML files for the rendering. For the web app we will use Flask for creating the web application and Psycop2 to interact with the Postgres database. Flask name is used to set up Flask to know where to find templates, static files, and other resources related to the application. The name indicates the current Python module as the base path for the application. @AppRoot / is a decorator that binds a function to a URL root. In this case, the root / corresponds to the root URL of the Flask application. Therefore, when the user will access the root URL of the application, it will call the function index that simply renders a HTML template to display some actions as create_table, insert_data, query_data. @AppRoot, create_table, methods sad_smiley_get, post. With this line we create a root for the URL path create_table. It can accept both post and get request, that is, it can allow us to view the page and submit a request. In this case the post action will just be to establish a connection to the database and create an empty table with name and age. If the request method is get, meaning the user is just viewing the page, Flask renders the create_table.html template. The insert_data route is for create table responds to get and post request, and it allows to add data to the Postgres table. As before, if the request method is get, meaning the user is just viewing the page, Flask renders the insert_data.html template. The query_data is just used to view the data and doesn't need the post request. By default it will allow to receive get requests. Finally, clean_table will allow to empty the table on the database. The next block of code is used to ensure that the Flask development server starts only if the script is run directly. The host equals 0.0.0.0 argument means that the server will listen on all public IPs of the host machine, making your Flask app accessible from any device on the network. The port equals 5000 argument specifies that the server will listen on port 5000. Now that we have seen our simple web app, we need to define a Dockerfile to create its image. It will do the following operations. Use an official Python runtime as a parent image. Set the working directory to app. Copy the Python application files to the container's working directory. Install required Python dependencies defined in the requirements.txt file. Expose port 5000 for the Flask application. Run the Flask application. Let's now explain the Docker Compose that will allow to build the images of our app and of our database. The Docker Compose file sets up two services, a web application and a PostgreSQL database. The services are connected to a custom network, enabling communication between them. It first of all specifies the version of the Docker Compose file format being used. In this case, it's version 3. This Docker Compose file defines two services, web app and Postgres, along with a custom network called Mindtwork. Let's analyze the web app service. Build. This section specifies how to build the Docker image for the web app service. It uses the current directory, as the build context and Dockerfile as the Dockerfile to use. Ports, maps port 5000 on the host to port 5000 in the container, allowing external access to the web application. Volumes, mounts the templates directory on the host to the app templates directory in the container. This is a way to share files between the host system and the container. Depends _on specifies that the web app service depends on the Postgres service. This ensures that the web app service starts only after the Postgres service is up and running. Networks attaches the web app service to the custom network called Mindwork. Now let's see the Postgres service. Image specifies the base Docker image for the Postgres service, which is the latest version of the official PostgreSQL image from Docker Hub. Environment sets environment variables for the PostgreSQL service, including the database name, username, and password. Ports maps port 5432 on the host to port 5432 in the container, allowing external access to the PostgreSQL database. Networks attaches the Postgres service to the Mindwork network. Finally, it defines a custom network called Mindwork. Both the web app and Postgres services are connected to this network, allowing them to communicate with each other. In order to build the images for the services defined in the file, you can run the Docker Compose build. Once the images are built, you can start the services defined in the dockercompose.yml file with Docker Compose up. Let's test our app. We can access it through the local hosts that appear when running the app. We can find 3 possible actions. Let's create the table. Let's now add some users to the table. We can query the data from the database and display it. If we want, we can also clean the table. If we query again the table, we see that it no longer exists. With this video, we have seen how to define and run a multi-container Docker application. Moreover, we have learnt how to write a simple web application that adds data to PostgreSQL or query data. If you have enjoyed this video, I invite you to subscribe to this channel. See you soon with more videos coming.